I just want to provide you with a little bit of background on the Bristol Poverty Institute itself. So we're an interdisciplinary research institute here at the University of Bristol, and our role is to grow, develop and promote the poverty and poverty-relevant research community at the university and beyond, and to engage with other sectors and civil society together to work together to end poverty in all its forms everywhere. We take a multidisciplinary, multidimensional approach to poverty and try and explore it from lots of different angles, engaging with people with lots of different approaches and expertise to try and maximise the impact we can have. Our approach is driven by our mission to explore the interface of different social, political and environmental considerations of poverty, with the ultimate aim of translating our research on the causes, effects and measurements of poverty into evidence-informed policy and practice. So we have three fantastic speakers here today who will share with you their work on carbon offsetting through the provision of clean cooking stoves and how this can impact not only on our ambitions towards becoming net zero, but also directly and indirectly on the lives of people in poverty. Our first presentation comes from Professor David Gordon and Dr. Cynthia Fonta, who have been working together on the Travel Carbon project, which this event is titled after today. We'll then move on to a presentation from Dr. Sam Williamson, who does great work on sustainable energy. So I'm going to introduce our first two speakers and then hand over to them for the really interesting stuff. So Professor David Gordon is a professor of social justice here at the University of Bristol and is also the director of the Bristol Poverty Institute and a world-leading expert on poverty measurement and research. He provides research leadership for multidisciplinary poverty-relevant research across the University of Bristol and has written and edited over 200 books, papers and reports on poverty, health inequalities and social exclusion, social justice and social policy. David is a member of many prestigious advisory boards, societies and networks. In 2006 and 2007, he was given the tremendous honour of addressing the General Assembly of the United Nations about child and youth poverty. And in 2018, he had the honour of being elected as a Fellow of the British Academy for his work on poverty research. And Dr. Cynthia Fonta, who is presenting with David today, is currently undertaking a PhD programme in health and wellbeing at the School for Policy Studies at the University of Bristol, supervised by David Gordon and also Zoe Tumbukari. Her PhD project focuses on child poverty and health inequalities in Francophone and Anglophone sub-Saharan Africa. Prior to enrolling as a PhD student, she worked as an independent researcher at Research Institute in Burkina Faso and also served as both a volunteer and a consultant for UNICEF in Burkina Faso. She's also a qualified medical doctor and previously worked as a GP in Nigeria. Her main area of research interests are in community medicine, health inequalities and well-being, and child deprivation and poverty. So over to them for our first presentation today.
Thank you very much, Lauren. Can you all hear me? Yes, great. Can everyone hear me online? Great. Okay, let me the next slide. Okay, I'm going to talk to you about carbon offsetting, salvational instrument of the devil. I thought I'd start off by tackling the contentious issue. But before I do that, this project, originally started as a final year computer science student project. Unfortunately, shortly after that project began, COVID came along and they weren't able to implement the full plans of that project. The idea was to mine the university's available data systems and provide every member of staff with information on how much their work-related travel, the travel they pay for from research grants and for going to conferences, how much CO2 they were producing, and to provide aggregate information to heads of schools. So they could see how much they were producing compared to people in their own faculty and in the university as a whole, as a way of trying to give people the information they needed in order to do behaviour change or to mitigate the effects of the CO2 they were producing. The other purpose of it was to provide evidence to the UKRI that they should allow carbon offsetting to be written into research grants. At the moment, the UKRI doesn't allow you to include carbon offsetting costs, even though they have a commitment to get to net zero by 2030. So, the students were very dedicated. COVID came along. I had one session with them online where every single one of them had COVID, and I had to stop it and tell them all to go to bed, and we'd meet in a few days' time. So I'm going to talk about some of the things, the reasons behind this project and some of the ways we've developed it since. Okay, so what's the problem? Why is it necessary? Well, if you look at what's happened to the climate since 1979, what you find is that all the greenhouse gases, carbon dioxide, methane, nitrous oxide, have been increasing. The surface temperature of the sea has been warming. The amount of ice has been contracting. The oceans have been heating and they are acidifying. Sea level has been rising. And extreme weather events have been increasing, and the cost of dealing with that has been increasing. If we look at the amount of CO2 in the atmosphere, what we find, that's last year, 2022, is that the amount of CO2 currently in the atmosphere is higher than it has been for 800,000 years, according to the records from the ice cores. The last time CO2 was this high was not in the present geological era, the Quaternary era, the era of ice ages. You have to go back to the previous geological era, the Tertiary, to the Pliocene 3 million years ago. If we look at an assessment from all the work that's been done on Pliocene climates, this is a summary from Professor Alan Hayward's work at the University of Leeds in a recent meeting of the Royal Meteorological Society. He says that, from the evidence, synthesising the evidence, that during the Pliocene, temperatures were between 1.8 and 3.6 degrees warmer, and precipitation was about 6% greater. There's a clear pattern of warming of the poles, and the Arctic Ocean was likely to have been ice-free in the summer, and the forests reached to the Arctic coastline. The tundra had disappeared. The Greenland and Arctic ice sheets had lost mass, particularly West Antarctic ice sheets. It's difficult to reconstruct the sea levels. Estimates are between 6 meters and 35 meters, but the average estimate is between 10 and 20 meters. To put that in context, somewhere between 500 million and 1.5 billion people live below 20 meters in coastal areas that would flood. So a lot of the major cities, London, New York, Shanghai, would likely in part sink beneath the waves. So if CO2 levels remain this high, for the long term, you don't want to buy a house in Bedminster. You'd rather buy one up on the hill in Clifton, because the long-term prospects for low-lying areas in Bristol are not good. What Professor Hayward says is, after studying the Pliocene for 21 years, and all things being equal in the decades ahead, that he will experience firsthand a climate state that has not existed for 3 million years. He's going to see what the world will be like, rather than just trying to work it out from the geological record. Okay, so one potential way of slowing down and ameliorating the amount of CO2 that's being produced is through carbon offsetting. This is somewhat controversial, in part because it has generated so much fraud and crime. So, the world's largest carbon offset program, the Clean Development Mechanism, was set up in 1997 as a part of the Kyoto Protocol and has supported about $90 billion in renewable energy investments in developing countries, equivalent to about 13% of the total investments. However, a recent assessment by the Climate Change Economic and Policy Group and the Grantham Research Institute has argued that about half of that money has been spent on projects that would already have happened. And of course, a lot of carbon offsetting has just been organised crime. There have been VAT carousels which have stolen billions of pounds. This trial in France led to the conviction of 36 people, many of whom are still not in jail. They've fled to other countries. And even the new carbon initiatives about forests, leaf, are seen as problematic by many people. There has also been a lot of greenwashing of major corporations through carbon offsetting. In particular, the UN carbon trading system called READ, Reducing Emissions for Deforestation and Forest Degradation in Developing Countries, was never implemented, and a Washington-based NGO called VERA provided a source of accreditation. What they did was to use the UN's proposed UN accounting methodology, but they did it with what was called a lighter touch. This was problematic, but the CEO of VERA said, if you require perfection, i.e. following the UN methodology rigorously, you'll have hundreds of millions of dollars worth of climate action. If you're more pragmatic about it, i.e. not so rigorous, you might have 2 to 5 billion. The problem was that a lot of the carbon credits that were bought and the projects they are meant to underpin are of very dubious quality. You have conservation groups selling carbon credits for not cutting down the areas they're meant to be conserving, even though they never intended to anyway. More recently, at COP26, Alok Sharma and the British government launched the Voluntary Carbon Markets Integrity Initiative to try and clear up this huge mess. And they launched its core carbon principles in June 2023, which aim to deter dubious offsetting and greenwashing claims by large companies. Trove Research, which have a long history of working in this area, looked at 470 large corporations which were currently using carbon credit schemes to offset the CO2 they produce, and they found that virtually none of them met this new integrity criteria. Most, 95% of the carbon credits they were buying were probably greenwashing, if you use a rigorous criteria. Of course, the Environment Agency and the UK government sees a role for carbon offsetting, and they have towards net zero, and they've looked at different methods of doing it. You won't be able to see this, but basically what you want is for all this circle to be green. The ones that come out as most likely in terms of cost effectiveness and quality of science, etc., are planting new woodlands and upland peat. The problems they have is they take a long time to get the carbon out of the atmosphere. Things like heat pumps and insulating people's homes have a problem that they don't last a long time, but they're much quicker. Now, despite the problems in the past with carbon offsetting, and you have to be very wary, as I say, it's an area where there's been a lot of fraud and organised crime. If you do it the right way, you can reduce poverty, you can reduce greenhouse gas emissions, or at least lower them, you can improve living conditions, and you can save people's lives. This shows from a large sample of the travel agent data, the estimated distribution of CO2 from work-related flights from University of Bristol staff going to research project meetings and conferences. The school which has the most emissions, about 2,000 tonnes, is the Bristol Medical School. it would cost £24,000 to offset their CO2 emissions from air flights. If you were to help purchase efficient stoves in sub-Saharan Africa, and this would save approximately 270 disability-free years of life from the population of Gabon, or if you just spread it across sub-Saharan Africa, 136 disability-free years of life. My own school policy studies, you would still save a significant number of people's years of life disability-free. I'll now hand you over to Dr. Cynthia Fonta to explain the basis behind these calculations.
Okay, good afternoon, everyone. I hope everyone can hear me. I'm here to talk to you about the Travel Carbon Project. So far, the progress the University of Bristol have been making to attain their net zero carbon, and also ways in which the university can tackle poverty and health inequalities in sub-Saharan Africa or in any developing country. So this is the outline of the presentation. I will start by talking about the university's carbon footprint so far, and then the health and environmental implications of household air pollution, which emits by the use of solid fuel use. And then I'll be talking about the gold standards methodology, which estimates the health benefits of the intervention which we hope to propose, in this case, improved cooking stove, and then the cost effectiveness of the intervention, and then conclude. So as we all know, of course, clean air is vital to health and the environment if we want to live another 200 years on this planet, of course. And just like so many other corporations and institutions and country governments, the University of Bristol adopted a carbon neutral position in 2015. And they agreed to, they're committed to working towards a net zero carbon by 2030. And so a series of mitigative measures were undertaken by the university, which has resulted to some progress. So far, there have been some reduction in carbon emissions from the university buildings between 2007 to 2018 by about 38%. While this is a useful place to start, but they realized in 2019 that they wouldn't achieve their targets if at this rate of reduction. So they would need like 90% of reduction to attain their 2030 goal of net zero carbon emission. And so through its scope 3 emission, the previous ones focused on scope 1 and 2, which were carbon emissions from the university buildings. And so they decided to include in their scope 3 emission to also tackle carbon emissions from other university activities, like from their supply chain, from their construction, and from academic and business travel. We can see from the diagram that emissions from transports was about 35% higher than from the energy released from other buildings. And so, again, we see from these graphs that international air travel constitutes the bulk of carbon emissions from the university. Between 2010 to 2018, air travels, carbon emissions from air travels have doubled over the years. And again, about 93% of all travels emissions are from air travels. Again, a lot of money, the bulk of the expenditure for travels is for air travels. And so through its sustainability plan, the university understood that they have to also look at ways of reducing all forms of travel-related carbon if they have to attain their net zero target. And one way of doing this, which we are proposing, is through the gold standard methodology, which, as Professor Gordon mentioned, it's a way that the university can engage in a low carbon emission project in a low or middle income country as a way of offsetting its carbon. And in this case, we are proposing to use improved cooking stoves. Cooking stoves, because cooking is a day-to-day activity, and it's what every household engages in. And again, over 3 billion people across the world rely on solid fuel use for cooking. While this solid fuel use have drastically reduced in much rich countries, the bulk of it still remains, is being used in Africa and Southeast Asia. From the graph, you can see that in sub-Saharan Africa, more than, in about 3/4 of sub-Saharan African countries, more than 70% of households rely on solid fuel use. And this is mainly driven by poverty, population growth, which exacerbates overcrowding. And as a result of this, most households, the demand to meet the large households, they rely on on cheaper fuel use, which the cheapest type is using solid fuel, charcoal and wood, which can supply the large households. And children and women they bear the burden, because women are the ones who are always cooking, and girl children as well. And then sometimes put the babies on the back, and so there are health and of course environmental implications to solid fuel use. The most common pollutant is the particulate matter with an aero diameter of 2.5, very small aerosol that can penetrate the lungs and can penetrate the vessels in the heart and the brain, causing strokes. It can cause ischemic heart diseases, and it can cause acute respiratory infections. And it also affects sleep quality, stunting. Most of the pathophysiology of mechanism of action can be further explored on this study cited on the slide. But one thing we can also look at is the the 2010 Global Burden of Disease, which was a study, a large cross-country comparison study that identified household air pollution as a significant risk factor to those mentioned adult diseases and respiratory diseases for children. And so they calculated the number of years lost to these diseases for those who were exposed to pollutants, to the air pollutants. So we'll see in the subsequent slides how important this burden of disease study is. And so there are 3 objectives in this project. The first is to estimate how much it will cost the University of Bristol to offset its carbon emissions from work-related air travels. And this can subsequently be used to write a grant application. And secondly, we hope to estimate the health benefits of the interventions, and measuring the health benefits in terms of the number of lives that can be saved and the number of deaths that can be prevented from using this intervention. And lastly, we will calculate the cost effectiveness of the intervention. So here is just an example of the traditional cooking methods in most African states. And on the right side, these are the graphs, the stoves, the improved stoves. They are called different names in different countries. So there have been some success stories from the gold standard projects. And for example, in Zambia, over 32,000 stoves were supplied to rural indigents, 60,000 in Rwanda, and most of the beneficiaries reported a reduction in smoke production, a reduction in cooking time, and also productivity. There was a boost of productivity. Most of the young girls could go to school, and women could engage in economic or income-generating activities. For the environment, there was less wood consumption and tons of carbon dioxide saved. So the gold standard methodology simply calculates the health benefits measured in terms of disability-adjusted life years, which simply means the years of life lost to a disease, and as well as the number of deaths that can be averted from using a clean cooking stove or minimal exposure to the particulate matter. To do this, we are going to use an internet-based tool, also known as the Household Air Pollution Intervention Toolkit. Simply input most of the background data, and it will use this background data to estimate the lives that can be saved with minimal exposure to the air pollutant. So first of all, we make a series of assumptions. 25,000 households were targeted, but of course at least 50%, we assume that 50% of these households will use the intervention over a period of 1 year. Each household would have at least 5 adults and a child. And our pre-exposure level is set as 285 micrograms per meter cube, and then the post-exposure level after the intervention is set at 140 micrograms. So these are the model inputs. We have the background data, which is based on the 2010 disease background data, which calculated the number of years of diseases associated with certain medical conditions. Those estimates have already been done. And then we also have the population of each country, then the proportion of solid fuel use, and the GDP, as well as the average household size. And so basically you have the amount of DALIs, the amount of DALIs associated with this level of PM2 exposure, and then the amount of DALIs associated with a minimal level of exposure. And then the difference will show you the number of years of life that have been averted. So based on our first objective to estimate how much it will cost the university to reduce, to offset its carbon from engaging in a low carbon project, the gold standard project assumes that each intervention saves 1 ton of carbon dioxide equivalent. And so based on the cost of stoves, the prices ranges between $4 to $11, some $15. It can go as high as $25, but we'll just take $14 based on previous studies. And so if at $14, we expect that the university can save a ton of carbon dioxide. And based on the fact that the university's travel carbon emissions in 2018 was estimated at 13,000 tons of carbon. So it brings us to $182,000. So it means that the University of Bristol would need to spend at least $182,000 to purchase 13,000 improved stoves in a developing country to save lives. So this is the Happy Models output. The darkly shaded areas just simply represent the number of years of life that have been saved from using an improved cooking stove based from these diseases. We can see this is in Benin. This is an example for Benin. And so number of years of life saved from acute respiratory infection for children, if you have to use this improved disease, is about 145 micrograms per meter cube. Again, the number of years of life that can be saved from chronic obstructive pulmonary diseases if you use an improved cooking stove, and it goes on. The lightly shaded areas are in a counterfactual scenario. That is, if all 25,000 households are using the intervention and are properly using the intervention, and with very minimal exposure to the pollutants, the PM 2.5, then you will have this much number of years of life. That's in the counterfactual, but we are going to stick just with what's happening in the real setting. So this is just a representation of the number of years of lives that have been saved, that can be saved by using an improved cooking stove. So if the University of Bristol supplies about 13,000 stoves to, for example, Gabon, the total years of life that will be saved is approximately 1,653. And it goes on to South Africa, Lesotho, depending on which country of choice. The same thing with the number of deaths. This is over a period of 1 year. And so averagely, spending $182,000 could save on average 876 years of life lost to disease and 26 deaths in sub-Saharan Africa in a period of 1 year. And so the last objective is to calculate the intervention cost. And this is simply dividing the total intervention cost, which is the $182,000, to the total averted DALYs. And so that gives us the figure on the right of the slide. So in principle, for University of Bristol to offset its carbon emission in order to reach their zero net carbon targets, they could supply improved cooking stoves to a low or middle income country, which on average could save lives and reduce deaths over a period of 1 year. They can save about 13,000 tons of carbon dioxide. They can save 17,000 tons of fuel wood consumption, because fuel wood consumption would be less, and also reduce deforestation and some economic benefits from that intervention. So I think that is all. So here are the references of my slides. Thank you.
Great, thank you very much, Cynthia and Dave. Those fantastic presentations. So we're going to do the Q&A at the end after all of the presentations. For those of you online, if you want to start typing, go ahead. But we're just going to move on to our next presentation before we open that up. And this is from Dr. Sam Williamson, who's a senior lecturer in electrical and electronic engineering, again here at the University of Bristol. Sam works on various aspects of sustainable energy, linking into considerations of environmental protection, economic longevity, social acceptance, and policy support. His research investigates ideas for sustainable energy across access through the concepts of renewable energy, microgrids, and whole energy systems analysis, with the aims of supporting international climate targets and working towards achieving the UN's Sustainable Development Goals. His research targets empowering and enabling communities, both large and small, to be able to support themselves using tools, techniques, and services locally available, especially in international development contexts. This includes work on clean cooking stoves in Nepal, Sierra Leone, and Uganda, which links in with our Travel Carbon project. So over to Sam, tell us a bit more.
Thank you very much, Lauren. So hello everyone and welcome, thank you very much. So I'm going to talk a little bit more about the stoves themselves and some of the interventions that we've been working with our partners with over the last few years. We've been working in Bristol, we've been working in clean cooking, or certainly in our area, for about 5 or 6 years now. So first of all, I wanted to bring up a picture of this. So this is a barbecue, and in the summertime a lot of people love cooking on barbecues, and If you go to the Downs here in Bristol, they're covered in them quite often. And I'll be perfectly honest with you all, I hate barbecues. I dislike them greatly. You spend an hour waiting for the charcoal to heat up to be able to run the barbecue. You try and cook your food, and quite often it's raw. It takes a long time to do, or you overcook it. It's not always a nice way of cooking things. But imagine that you effectively had to cook on a barbecue 2 times a day, every day. Doesn't mean you don't have the skills to be able to do that, and it was great to see Cynthia's images of the 3-stone stoves. And so we've been working, as Lauren said, in Nepal, and also in parts of sub-Saharan Africa, so in Sierra Leone, Uganda, and in the Gambia recently, thinking about how people use stoves and how we can transition to cleaner stoves. And just to give you a bit of an image about what it's like trying to be in this area. So we can talk about PM 2.5, and we can talk about CO2 emissions. We can talk about carbon monoxide emissions. But actually, if you sit inside a room where a stove is going, and especially if it's using highly resinous wood, your eyes start to stream. You cough, and you can't get rid of that cough. The physical realities of what are happening is really unpleasant. And it's what 3 billion people are doing at the moment. And so I think that gives us an imperative to try and look for moving forward and trying to find a better way. And it's not only the actual process of cooking, it's getting the fuel in the first place. Again, Cynthia mentioned about issues around deforestation and environmental degradation, which happens on a local basis. And if you look around, there are maps around refugee camps in areas in sub-Saharan Africa where the communities have to move further and further back to be able to collect their firewood. And you just see these rings, basically, of how where firewood is. In Nepal, some of these photos are from our partners in Nepal and in Sierra Leone. In Nepal, people carry 25 to 50 kilos of wood on their back. If you're in the hills are proper hills, and they're 45 degrees. And it's a lot of work to be able to carry this. And it's often down to women, younger women, and older women as well. And this can take up to a day a week to be able to go and collect the wood for that week, which is a lot of time taken away from education, a lot of time taken away from other things you can do, a lot of time taken away from leisure, and to actually try and enjoy life. If you look at charcoal, charcoal is, as Cynthia mentioned, charcoal is a common fuel. Some of the research we've been doing in Freetown, in informal settlements, we found that 96% of households use charcoal as their main cooking fuel. And similarly in Kampala, we've done a similar thing, and it was 95 or 96%. Now, charcoal is actually a very useful fuel. And I say that because it's the original pay-as-you-go fuel. Imagine you have £1, you can buy £1 worth of charcoal. If you have £10, you can buy a big bag of charcoal. If you have £100, you could import a load of charcoal, and if you can store it, you can keep it in your house. So you're able to vary your use of your fuel depending on how much money you've got. And that's really powerful for a community where you don't necessarily have a guaranteed income all the time. And so there's this sort of mix quite often between charcoal and firewood, and people pay for what they can afford and buy as much as they can afford as well. And we actually found through some of the surveys that we did that people would, in months where they were a bit leaner and didn't have as much work or weren't able to generate as much income, then they would reduce down to cooking one time a day rather than the standard 2. So there's a lot of challenges around this. Again, I'm not going to go over the health benefits. I think Cynthia's done a fantastic job there. But the challenge is trying to improve health, trying to improve the situation for the people who are cooking. And again, it's women, it's children, it's the elderly. It's the vulnerable members of society that are being affected by this. But not only that, cooking is a highly cultural thing. So we're taught how to cook by our family and our parents, and our culture goes through that. So in Nepal, they've had a number of schemes trying to support using improved cook stoves and ideas around something called biogas, where you collect together animal dung and waste, and use that then to generate a gas, which can then be piped into the house. But actually, that transition has been quite difficult because people aren't used to cooking on these types of stoves. So the picture here on your right is a smokeless stove in Nepal. But actually, I went into a house where they had a smokeless stove and an equivalent of a 3-stone stove. And they used the 3-stone stove because they preferred that. They preferred the taste that came from the food. They also found that the smokeless stove didn't keep the flies away as the standard stove did. And so there's real cultural challenges around what's going on. But there's opportunities here as well. So a lot of the work that we've been doing is looking at a transition to electric cooking. There's a £40 million project running out of Loughborough, funded by the Foreign and Commonwealth Development Office, looking at modern energy cooking services. And they are really pushing the idea that you can bring electrification alongside electric cooking. And the phrase they used at the beginning of the program was killing 2 birds with 1 stone. If you have good electrification and you bring along electric cooking at the same time, then you get a good demand on your grid, and you're able to support that. And so having a clean kitchen, you can see in the picture on the left there that there's no, the stove and the cook pans don't have smoke and soot all over them. It's generally a cleaner place to be able to work, and it's a nicer place to be able to work as well. Some of the comments we've had back from our research that we've done in Nepal is that basically the cooks felt more comfortable in the kitchen. They could stay there longer. They didn't have to worry about their children so much. But also, a lot of countries are developing their electrical infrastructure. And so this gives an opportunity to strengthen that electrical infrastructure, provide access to people to electricity. But also, if you're building large renewable projects, so in Nepal, again, they're going to have an excess of electricity generation. So they need something to be able to use that. They need a demand to be able to use that. And so that will really help with that. So these two things can go hand in hand with each other. So I just wanted to talk to you about some of the trials we've been doing in Nepal, because I think they give a good sort of overview about some of the challenges and some of the outcomes that we've got so far. So we've done some specific trials in off-grid communities where they have small-scale micro hydropower systems, so using river flow and diverting the water off through a small dam that passes through a pipe and impacts on a turbine, can generate some power. And one of the issues around these grids is they're constrained. So they only have a fixed amount of power that you can actually pull off the grid. And so that is one challenge with off-grid systems that you might not necessarily have with an on-grid system. So there are 3 different trials that we've did. So in 2018, we did a trial in an area called Rukum, which is in sort of northern central Nepal. And in Rukum, we were looking at just actually, could electric cooking work in Nepali culture? Can we cook Nepali food in communities, and would people go ahead with that? Because that's the first question. Is this going to work? Is there any point in trying to do this? After that, we were trying to think about, okay, well, what's the social and cultural acceptance of electric cooking? Is this something that people will actually take up and try and keep going with? And so we worked in an area called Solukhumbu, which is in the sort of foothills of Everest. And we worked with a community there to be able to try and understand whether they would accept the cooking, whether they would accept electric cooking or not. And then, because we were on this highly constrained grid, we then thought about trying to use more efficient cookers. So we could get more cookers on the grid to be able to use more power and enable more people to be able to cook with the electricity that's available. And we did this both in an off-grid situation, again back in Solukhumbu, but also in an on-grid situation where people are in a rural area in the Kathmandu Valley. And just to see how people would use these electric pressure cookers. We've also, at the beginning of last year, we finished a study looking at urban cooking as well. And so thinking about, could we actually get people to transition from however they're cooking to 100% electric cooking? Will that work? And just want to quickly go over some of the methods, because I think how you do this is really important. A lot of development organizations will go in and donate things. That's their typical mechanism. So you'll go in and donate solar lanterns. You'll go in and donate a stove. But actually what we've found, and through the work that Loughborough have done through their MEX program, is that doesn't work particularly well for cooking necessarily, especially when you're moving to a technology that's very different. And so we've developed, I would say, with the support of Loughborough and using some of their protocols, we've developed a methodology around this. And so our partners in Nepal, they built their own electric kitchen first of all in their offices, and started to work out how to cook food and how to cook local Nepali food with the cookers that we were providing the community. And through that, then we would go into a community, or our partners would go into the community and do a demonstration. So at the top here, you can see the lady in the center is one of PIDA, our partner in Nepal, is from PIDA, and she is demonstrating how to use an electric pressure cooker. Now, Nepalis are quite used to pressure cookers. They're quite good at cooking rice, and they're quite good at cooking dal in pressure cookers. In fact, they're amazing at cooking both. They're not just quite good. But they won't necessarily have come across something like an electric pressure cooker where you have to put settings in and understand what's going on. And so showing them how to cook their food that they learnt, the PIDA team learned how to do in their own kitchen, and then demonstrating that to community members was really important, a really important step within our process. And then from that, then we would record how people cook. So prior to the intervention, we would find out how people cook, and we'd spend 2 weeks recording how much fuel they would use, what food they would use, everything about the meal, everything and anything about the meal. We would weigh things. We would how many times they would have cups of tea, and record that down. And then once we've delivered the electric cooking stoves, then we'd also run that again. And one of the trials we did on the electric pressure cookers, it was a 6-month trial. And so we ran these after the end of the trial as well to understand what had changed. So I want to sort of just highlight some of the key outcomes that really came from this. And we did find that families were able to transition reasonably well to electric cooking devices. There were challenges, but they were able to do this. And a lot of people wanted to be involved in this trial. And one of the challenges was actually selecting the right families to be able to do this, because we couldn't do it with everybody that we wanted to. One of the, I'm going to say innovations, and I don't think it's necessarily an innovation that we did with the electric pressure cooker trial, was we had something we called the marketplace. And we subsidized 100 electric pressure cookers and said, come along and buy one if you would like to have a go. And this was about 3 months into the main sort of intervention program. And we had so many people applying for our electric pressure cookers, we were quite surprised. And people really wanted to have them. One of the things that was actually quite interesting was that fuel stacking was widely used. And so what do I mean by fuel stacking? Using different types of fuel to cook things. So actually, I'm going to go back a minute. You can see here, we've only got one hob. We've only got one place that you can cook something quite often. Most places only have one burner, so you can cook one meal at a time, one dish at a time, sorry. But now, if you have a new electric cooker, you could cook rice in your electric cooker, and you could cook your vegetables or whatever it might be on your stove, on your wood stove. And so a lot of time people were saving time by stacking their fuel, cooking concurrently, rather than cooking consecutively like they had to do. And so a lot of the comments that came back from the communities that we worked with was that they were saving time in their cooking, which was something that we hadn't really ever thought about necessarily. We showed through these 3 different cooking trials that actually the cost of cooking with electricity was lower than the cost of cooking with LPG or with biomass. And to give you some numbers around that, with the electric pressure cooker, we're about 6 to 7 rupees per meal. We had an induction stove, and that was about 11 rupees. LPG was about 12 rupees, and cooking with biomass was about 13 rupees. And so to the induction stove, there wasn't a huge difference, but to the efficient stove, the EPC, there was a large difference. And so alongside that then, there was a huge reduction in energy usage. Biomass stoves are incredibly inefficient. They're really, really inefficient. So people, you might be using, say, 5 or 6 kilowatts whilst you're cooking. Whereas with an electric stove, you're using, on average, less than 1. And so this huge difference in energy consumption is there. Grid-connected households, so for our on-grid study, they were saving between 30 and 60% of their costs. Most of them were on LPG, and some of them were on biomass. And if you just used the electric pressure cooker to be able to cook rice, which in Nepal is a staple and most people cook at least once a day, if not twice, then we found households were saving up to 50% of their firewood. So they could go out every 2 weeks to go and collect their firewood instead of 1 week. One key issue we found was that there was device reliability was difficult. So making sure that the devices could actually stay operational. We had issues around cockroaches climbing inside and effectively laying their eggs on some of the circuitry, which then caused short circuits and things blew up. But also, there wasn't the knowledge in how to fix them as well. And so our partners in PEDA, they did a lot of work backstopping and were on the phone with the teams or the community constantly trying to support them in fixing or in providing new devices. One of the interesting things that we found as well is, although people cook around the same time, so between about 6 and 9 in the morning and about 5 and 8 in the evening, just because you have 10 cookers on a grid does not mean you have 10 times the power of that cooker on the grid. And so this curve down the bottom sort of tries to demonstrate that a little bit. The lower green, you can see, is actually the 10 EPCs. And you can see that they're only, so each EPC had a power of about 900 watts. And they were bringing about a 2 to 3 kilowatt power draw from the system on average. And so we could we had a very, very small amount of power draw, even though we had 10 EPCs on there. And when we went up to, when we had a much higher higher number, again, we were only going up to about 10 kilowatts for an additional 60 EPCs on the system. And so you don't have to just add up the power of each device and then say, well, this is how much spare energy you need, spare power you need on your grid. And I think that was one of the interesting things. Actually, the PhD student who did a lot of this work wrote a paper about this and tried to quantify this a bit more. This is a graph, or one of the outcomes from our study in 100% electric cooking. And what we found is that, so you can see on the bottom is all the different dishes that they cooked in Nepal, and on the y-axis is the percentage of usage of a particular cooker. And you can see here the orange, which is the electric pressure cooker, was really used a lot for rice. But for everything else, it wasn't used very much at all. But traditional dishes or other dishes, such as vegetables, such as dal, eggs, meat, and things like this, were actually used on the induction cooker. And that means, so we found that the induction cooker was a lot more flexible, but it wasn't necessarily as efficient as the EPC. And so it was an interesting sort of trade-off, I guess. And one of the things we did with this trial as well was we gave everybody an induction cooker and an electric pressure cooker just to see how they would use the different devices. It was sometimes a challenge to cook staples on the electric devices. So the roti, the sort of flatbreads that traditionally cooked in Nepal, they're really difficult. They're pretty much impossible to cook in electric pressure cookers because they don't get high enough and you can't get into the dish to be able to do that. And on induction cookers, you need to have a very thick pan to be able to spread the heat around the dish to be able to get a nice even cook on it. And so things like that were quite difficult, and deep frying things were very difficult as well, especially with low power cookers. But one of the things we have done from this work is actually create a Nepali e-cookbook. And so through this e-cookbook, there are a number of different recipes that you can use electric pressure cookers for, and shows you how to be able to cook this. And so this is part of sort of the dissemination of the ideas and devices around it. I think one of the other things that really came out of this was that in the constrained grids and off-grids that we were working with, getting everybody to cook using electricity is not possible, certainly at the moment. And we'd have to look at ways of managing it. Even if you had all of the energy that the constrained grid was providing and were able to spread it out over the day, it still wouldn't be enough quite often. And so we'd need additional generation, or we'd have to accept that there would be some of this fuel stacking between firewood and electricity. I just wanted to highlight something that we're actually doing currently at the moment, working in Sierra Leone as well. So one of the challenges with electric cooking and even improved cook stoves is the cost of them, especially for poor communities. And so we've been working in an informal community in Sierra Leone for the last 3 years, or nearly 3 years. During a survey process, we asked them, what do you want? What do you think could help you transition to improve cooking services? And they said, well, why don't we have a community kitchen? Why don't we all cook in the same place and share stoves? And so we're at the moment working with our partner in Sierra Leone, the Sierra Leone Urban Research Centre, SLURC, to develop a community kitchen to see if this will work. And so we're designing, we're building, we're trying to work out how to manage and operate that system so that people can come in and effectively, again, pay as you go to use their stoves, pay as you go to use these improved cook stoves. And that will mean that people don't have to necessarily fork out the capital to be able to pay for the improved cook stoves, but instead they'll be able to use that, the little bits of money that they have to be able to pay to cook. And we're really keen and interested to understand, is this going to work? And I don't know what the answer is to that. I think it's a really interesting project. And just to say, this is a very simplistic view on things, I appreciate. And I appreciate the flaws along with the SDGs. But if you look at clean cooking, I think there's a number of SDGs that it really hits well. Thinking around poverty, thinking around good health, education, gender equality, thinking around access to renewable energy, so effectively modern energy for all, sustainable communities, climate action, life on land. It hits a lot of these. It hits a lot of these SDGs. And so if you're thinking about sort of impact towards SDGs, then clean cooking is a real good way forwards. So I'm really happy to answer some questions in a minute. I would, as I say, really like to acknowledge all the partners that I work with. Like, they do amazing work, and they're a key part of what we do. And also the researchers, so Will Clements, who's now working actually for the MEX program, and Charlotte Ray, who's the RA that I work with on in Sierra Leone and in Uganda, and some of our funders, so MEX and Bristol as well. And if anyone's interested, there's a few references to some of the documents that and reports that we've written there. So thank you.
Great, thank you very much, Sam, and thank you to all of our presenters. So we're happy to open the floor up now if anyone's got any questions. We've got a couple coming in online, but I'll just open the floor up to the room first, and then we'll go to the ones online after that. Yeah, gentleman here. Yes, yeah, for the live streamers. Yeah, we do have a second one as well. So.
Thank you. So I think this clean cooking stove project is terrific, and I'd really like to extend my appreciation and congratulations to everyone involved in that. And hopefully nothing I'm about to say should come across as criticism of that. But I am troubled by making a connection between that very worthy, noble project and the university's travel emissions. So, I mean, David made an interesting comment earlier about you know, the impact of flooding in Bristol and how people in Clifton will fare much better than people in Bedminster. And that's, you know, that's what climate change is about. I mean, to a first approximation, climate change is about rich people killing poor people, both within countries and across countries. The World Health Organization estimates that 250,000 additional deaths per year between now and 2050 will be due to climate change, and maybe 90% of those will be in the global south. And nowhere is that disparity between rich and poor clearer than in our aviation behavior, because just 1% of the world's population is responsible for half of aviation emissions, and aviation is the fastest growing contributor to emissions. And we have a particular problem with that in academia because of our culture, because of the norms we have for career advancement. So it was very good to see the figures. I'm glad that people are measuring those figures in the university. That's obviously really critical. Other figures I've seen recently suggest that the UK's universities are responsible for 18 million tonnes of CO2 per annum. I think that's broadly consistent with what you're suggesting. Now, as well as looking at the accounting for how many lives can be saved through clean cooking, I think we also need to look at the other side of the ledger. One estimate is that there's one additional death due to climate change for every 1,000 tonnes of CO2. So if we plug those numbers in, that's 18,000 deaths per annum that UK universities are responsible for. And I think a troubling aspect of this for me is the implication that we can somehow compensate for those lives that we are taking by saving other lives. And perhaps another implication is that it is easier for us to go and change the behavior, the cooking behavior of, you know, potentially hundreds of millions of people in the global south than it is for us to change our own behavior. I thought it was particularly troubling to see Bristol Medical School topping that list. You know, first do no harm, I think, is an important maxim here. So, it is brilliant that the university is involved in helping to save lives of people in the global south, but we do also need to change our own behavior. And so, you know, can't we and shouldn't we indeed be doing both of those things?
That's really an important set of comments you've made there. I agree with you completely. The original project, as I said, was to provide every member of academic staff with information on how much CO2 they were producing from their flights and other business-related travel, as they put it through Ian Allen and the expenses system, because that's where it's measured from. Because it's clear that although people in general are very supportive of reducing their CO2 emissions, unless you give them the information on how much they're actually personally doing, it's hard to get that behaviour changed. Some people will, but some people won't, because there's work pressures for them to go to meetings in various places, particularly if we want to be an international university working internationally. That part of the project, I said, didn't get implemented entirely because of COVID, and that bit hasn't been funded. But what we wanted to see was, in the meantime, if we can't change everyone's behaviour overnight, we can't all get all meetings on Zoom, people are still going to do travel, and I think the fourth on my list was the international office. There's travel after the medical school and engineering, aeronautics. In order to mitigate the CO2 from that travel and reduce the number of deaths due to climate change, we can do that by planting trees in the UK, or we can do it in a way which will actually reduce inequalities, improve people's lives, reduce poverty, because you don't have to spend so much on the fuel. You have a better living condition if there's not a lot of particulate matter, and you can actually save lives at relatively cheap costs. The kind of cost we would like to think that if we made a case to the UKRI, they would be willing to allow us to put into the research grants. Because 2/3, well more, 75% of that travel is actually from research grant funding. So if you could just put that as an extra line, it would be a negligible cost on your research grant in total, and you were to use it in a university scheme to actually do this one intervention, it would be beneficial in reducing the amount of extra CO2 that would go into the atmosphere, at least in the short and medium term, and actually be beneficial in reducing inequality and poverty and improving health, to offset the deaths from increased heat and flooding that will occur. I mean, there's no question about that. So this is a mitigation, it's not an answer, but the atmosphere doesn't care where the CO2 comes from. Yeah? So a ton of CO2 not going in the atmosphere doesn't matter. There's no morality as far as climate change is concerned. Yeah? There is morality as far as we're concerned. Yeah? So that's the idea behind it. Yeah?
Absolutely, this is much better than planting trees.
Yeah.
And this is an intervention that needs to be done and needs funding.
Yeah.
I guess my concern is just about finding the funding for that, from linking it to our own travel. Not once have I received any communication from the university suggesting, giving any guidance that maybe I might like to consider reducing my own travel emissions, might like to consider attending a conference virtually rather than using a ton of CO2 to give a 10-minute talk in New York. We need to look on our own doorstep.
If you drill down about 40 clicks on the website, you'll find some guidance.
I don't know how long this has been the case, but I noticed when you sort of book travel now, say for like a train ticket using the university travel system, Clarity, there's a little question at the end that asks you, could this travel be avoided through video conference? Quite small scale, but I don't know if others have noticed that and whether that's relatively new or...
But by the time you've gone through all getting Clarity to work, it's not going to be effective.
I do think there's a real call for us to look at how we change culture, how we move from this profession that says we want to do all these things and to support the fight against climate change, and still we fly to conferences all over the world, we fly to meet our partners, and we need to try and work out how that is, and I think we all have our own ways of justifying it to ourselves. And I'm not saying that what we say in our heads is right or wrong, but I think we need to try and instigate that culture change. How can we do that? How can we say, do you know what? I don't need to go to that conference necessarily to be able to present that research. I think the challenge is that, I think for me, one of the best research that I do has been through meeting people, and meeting people that has been through conference events. Outside of these collaborations, I work with a colleague in Brazil, and I met him in a British conference, British Academy workshop in Brazil. And we have been doing some amazing work looking at energy access in the Amazon region, and which will, I'm very sure, in the next 5 years will have some really good impacts and will support both poor communities, but also the consideration around what energy access is and what energy resilience might be. And so in my head, the time I went to Brazil to go and see him and work through some of those challenges, I was mitigating those emissions that I was making by traveling, by the work that we were doing. And I'm not saying, I don't believe that that's the right thing, but that's the reason I had in my head. And so it's this real way up between these two things of meeting people so you can collaborate and do excellent research which will be impactful and will change things, against traveling for just for a 10-minute conference presentation, which we've done as well, and I've had
Yeah, I don't mean to point the finger at anyone and try and do flight shaming. I mean that's not what I'm about. But one of the things that you hit on there, which I think is really important, is at least the perception amongst the general public of hypocrisy amongst academics. A couple of years ago, the University of Cambridge was proudly trumpeting at how it had reduced meat consumption on its campus by 25%, which is brilliant. And the Daily Telegraph responded with an article which had a figure showing how that impact compared with university air travel. And so, the message is, well, how can you academics in your ivory tower lecture us on what we should do when you're not even looking after your own affairs? And, as a leader in this space, which I hope Bristol aspires to be, being the first university to declare a climate emergency and so on, we have a role to play in trying to address some of those cultural issues within our sector.
Completely agree.
Was there any other questions from the room, or shall I move to the online ones? Okay, so I know a couple of the questions that we've had online mirror your first question there. So to avoid repetition, I'll go to some of the others. So a question that came in towards the end of Cynthia's and Dave's presentation at the start is from James at the University of Bristol, asking, how do the cook stove projects align with the core carbon principles of the Integrity Council of the Voluntary Carbon Market, and what are the implications for the proposal to use them to contribute towards net zero?
Well, the cook stoves are a very effective intervention, as I think the talks have shown. The core carbon market is about other kinds of projects, particularly the forestry ones and the integrity of those. So we haven't really looked, because the principles only came out, they're still not finalised, a few months ago, how they would fit in, but we can do that. Yeah. But I'm sure that it will fit into, I would hope it would count as a platinum level on that. I honestly haven't looked to try and see if it authorised. The intervention is highly researched and is highly effective, and the estimates Cynthia has presented are very conservative. They assume that if you gave 2 households an improved cook stove, only 1 household would use it, and they use the average household size of about 6 people in sub-Saharan Africa. And as you can see, there are overwhelming number of households in many African countries that are using wood fuel and solid biomass fuel, and that is highly harmful for their health and their wealth.
Great, thank you, David. Cynthia, did you want to answer that question as well, or are you happy with that's covered? Okay, great, thank you. So we also have a comment in the Q&A from James, who asked the previous question, who's helpfully shared a link to University of Bristol page on how you can reduce the carbon impacts of your business travel. So we'll move that into the chat window for anyone who's at the university who would like that guidance, and obviously it would apply to other people as well. So looking at the other questions that we've got online, again, they're in the same vein as the initial question of actually, should we really be talking about mitigating it, or should we be trying to change those behaviours, which I think we've already addressed in the room.
I mean, again, just to reiterate, I don't think it's an either or. I think we should do both. I think we should mitigate what we're doing and try and reduce what we're doing. I think it's Klaus Schwitz on war said the best is the best is the enemy of the good. I think we need to do the good because it's in all our interests to try and ameliorate the impact we're having on the climate.
Just to add, I think the University of Bristol is doing some mitigative steps through the Scope 1 and 2 objectives. And so if you go to their website, they have from their sustainability plan and some other documents, there are a series of steps that have been taken from the university buildings and what students commuting, and those steps are ongoing. So we can actually do the two. We can offset carbon, and we can also do some mitigative steps, which they have been doing. So the information is there on their website. Yeah.
And I guess James Rowell, who is the transport manager, who's in charge of this advice to academic staff. So please look at the link online if you haven't seen it.
Great, thank you. So that's our questions from online. So was anyone else in the room had any other questions or comments before we wrap up for today? Okay, then just see if any of the speakers want to make any final remarks, and then we'll call it to a close.
Thanks very much for coming and joining online. The terrible weather we're having, unfortunately, is going to get worse if the climate change models are correct. So maybe we can do more of these online and reduce our carbon footprint through travel. I'd also like to thank, which I meant to do at the beginning, the Ethics Committee of the Engineering, because they dealt with this application to provide us with all the information, personal information for staff, which isn't the normal kind of application they get, and they were very flexible and helpful. So thank you very much for listening.